Our next section is on parabolas, and we've worked with parabolas before in the quadratic section, but we're going to look at them in kind of a different way in this section. So a parabola has the property where all points on a parabola are equidistant from a fixed point called the focus and a fixed line called the directrix. And the focus is on the inside of the parabola, and the directrix is really behind or on the outside of the parabola. So if we look at these diagrams, we see a lot of information. We have our vertex, we have our focus, we have our directrix. We have something called the lattice rectum, and that's really just a fancy name for the width of the parabola at the focus. So this is really just the width of the parabola at the focus. We have two different formulas for the parabolas. In this version, it's really the x that's being squared. In this version, it's the y that's being squared. And the major difference is that if x is being squared, the parabola is either going to open up or down. If y is being squared, the parabola is going to open up either left or right. So then we have our vertex, hk. We have the lattice rectum length, which again is the width of the parabola at the focus. This is the absolute value of 4a. So whatever number is here, take the absolute value of that, and then that would be your width. So then it also helps to figure out what a is. So if you figure out what a is here, then if you add that to the vertex, you can get your focus. And if you subtract that from the vertex, then you find your directrix. Looking at number 1, I want to first figure out which way it's opening. So I see that the y is the term that's being squared. So y is being squared. And that means that it's going to be either opening up to the left or to the right. And then if I look at 4a, which is right here, it's the 8, that is positive. And that means that the parabola is going to be opening up to the right. So when I saw that y was squared, I knew it was either left or right, but then when it was y squared with a positive 4a, that number 8 is positive, then I know for sure that it's going to open up to the right. Next, let's look at the vertex. So my h is equal to 2 and my k is equal to negative 3. So because the formula has negatives, it's always really the opposite sign of whatever we see there. So it's going to be a positive 2 and a negative 3, because this is a positive 3 and a negative 2. So my vertex is 2, negative 3. Next I want to look at 4a. So 4a in the formula is right here. So in my problem, I have an 8 right there. So 4a is equal to 8. And that's really going to be the lattice rectum length, or the width at the focus. So I can just put the 8 there. It's technically the absolute value of 8, but because it's positive, it's going to stay positive. So next I want to figure out what a is, because that's going to help me find my focus and my directrix. So if you divide both sides by 4, a is equal to 2. Okay, I'm going to graph the vertex, and that's at 2, -3. So that is right here. And to get the focus, I want to add 2. And that means I'm going to the right, because right is positive. So this is my vertex, and add 2 to the right. That gives me my focus. So my focus is 4, -3. And then to get the directrix, I need to subtract 2 from the vertex. So that means I'm going to the left 2, and it's going to be a line. So it's really this vertical line, x is equal to 0, because that's the axis. Okay, so I'm almost done. I need to finish drawing the parabola. So the width of the parabola at the focus is 8. So because this is symmetrical, I need to cut that in half. So I need to go up 4 from the focus, and then down 4 from the focus. And then that will help me draw my parabola. And that's it.